Hello YouTube world. Today I'm going to show simulation of credit card account using a Struct and related functions. And I'm teaching at Santa Monica and El Camino College, and it's very useful for students there as well. I'm Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. So let's begin. Well, when you do credit card simulation, bank issues credit card to their customers, and typically they record information such as customer name, account number. After customers do shopping, they will owe some money. There will be annual interest rate on the credit card. If entire amount was not paid each month, there will be interest levied each month. There will be payment date. If payment was late, there will be late penalty charges. And there'll be a whole bunch of other things, like credit limit could be different for each customer, although it will be a constant for a while until it's increased or decreased. And the customer's address, phone number, email, all those things will be stored as well. So you can see that with these multiple fields, Struct or number of structs would be perfect data structure to keep and process credit card information. Okay, but here in previous slide we're talking about number of different fields, but we'll keep our credit card simulation very simple. We don't want this to become a 100,000 line software. We want to keep it simple. So we're going to have only limited number of fields and operations on the credit card. So fields will be just simply account number, customer's first name, last name, amount owed. And of course, in the previous slide I forgot. Actually, I did have customer name. So account number, first name, last name, and amount owed. That's all I'm gonna do to keep it small. And there'll be other items such as credit limit, etc. Now, number of operation in a real card could be huge, but to keep our software small for an entry-level programming course, we're just going to keep number of operations simple. First, let me show you the credit card struct that we're going to design. We're going to keep type-def version so that each time I declare a struct variable, I don't have to use the tag struct. So tagged version is more complicated, so we're not going to use that. So in this version, the keyword type-def and struct go first, then struct member, right curly brace, and that's the name of the struct credit card. Name goes at the end. So we're only going to record first name, last name. Max will be set to some number of characters, maybe 30. Amount owed and account number. So when an instance of credit card is created, it will have fields called first name, last name, and amount owed and account number. And operations we're going to do will be also not too many operations. We'll have operations to create a new account, do shopping, that means charge to credit card, make payments to credit card, print account details, change account holder's last name, get available credit, print credit limit. And there'll be more in a big piece of software, but we're not going to do that in this case. Notice Some of these change the state of an existing credit card account and some don't. That means some have read access and some have write access. Anytime you have write access, you're causing mutation in the software. When you do shopping, you're going to change the state of the credit card because you are going to be spending money. So amount owed is going to change. When you make payment, your amount owed will be reduced. When you do shopping, your amount owed will be increased. When you change account holder's last name, there's a mutation, change of the state of the credit card object. Okay. So you have to keep that in mind that some operations change the state of the object, credit card object, some don't. The one who change the state of the object have read access to the object, otherwise just write access. Like print account details, just prints it, doesn't really change anything. Same thing, getting available credit simply, or printing credit limit simply prints a portion of the existing state of the credit card object, does not change it. In C programming, these two operations are not that well discerned or differentiated, but more advanced object programming software like C++ or Java, yeah, there will be a big difference between the two types of operations. Okay, we're done with the PowerPoint. We're gonna now show everything in our compiler, keeping in mind what our struct is, what operations we're going to do, and we're going to show them. Each operation is actually a function, more or less. Some don't need a function. So we're going to change. Oh yeah, one more thing. When you change something using a function, we'll have to pass credit card struct as a pointer, because you passed it by value without a pointer, you can't change it. So that's a big difference. When we want to change a credit card or a struct passed to a function, we'll have to pass it a pointer to it in order to change it. Otherwise, we can't change it. Okay, so we'll see that too. So now we're going to show rest of it in our compiler Xcode. Okay, let me actually quit. So this is our compiler Xcode. I'm going to use flush because I'm going to be inputting some strings. This macro has been described separately. Maybe not described, but if there are any questions on it, I can describe it separately. But basically, when you do scanf, a character is left in the stream and flush gets rid of it so that you can have input for characters and strings. We have pound defined constant for credit limit of $1,500, and this pound defined max will be used for first name and last name storage, maybe other storage. And we're going to define a global static variable, initial account number 100. That means we'll use this to automatically create account numbers for new accounts that are opened. So during one simulation, first account open will be 101, second will be 102, and so on. So during creation of account, we don't have to ask anybody what the account number is. It'll be automatically generated using this static int variable. We can also make it const static, but I didn't do that, so we're not sure what the effect would be, or we can do a upon define also, but right now I'm gonna just leave it that way, since there could be undefined effect if I change it now, and I need to discuss this software right now. Okay, so we have two fields to record first and last name in a character array, then an amount owed, and then account number, which will be assigned automatically. We'll show how to do that. There is some explanation required about amount owed. In credit card business model, amount owed is positive if person holding credit card owes money to credit card company. Amount owed is negative if there is a credit balance in person's credit card account. This is exactly opposite of savings account in a bank, where if you overdraw, you owe the money to the bank, amount is negative, and amount is positive if your money is safe and you can withdraw money. So it's exactly opposite of the bank savings account. If credit card account is negative, that means bank owes you money. If it's positive, that means you owe them money. Okay. All right. So we discuss the operations, create an account. So we're going to discuss each operation as a function separately. So first is create an account, and we're going to jump to the definition. So in creating a credit card account, we ask user for all the information so that these struct fields will be populated, and then we return the credit card account created by return mechanism. So first we create a blank credit card that has nothing in it. This will be used a little bit later, because when we do fgets, end of the line character is appended, and we want to get rid of that, and it'll be used in that. So basically get all the user data and then return this CC after filling it. So first we ask for credit card holder's name, and we use cc dot first name field to store it. This simply says our storage limit, and input is from the keyboard. We wish to remove /n from the first name. That would be stored automatically if we did fgets. So we get the stir length of the cc dot first name, and /n will be at the location len -1. Don't forget cc dot first name is character array. So from len -1 location, we remove this, and instead we place a null character. So it's actually very simple. We do the exact same operations to get the credit card holder's last name. We first use fgets to get it, and I've described fgets in another video, and then we remove /n from that. So you can print first and last name without cursor moving to the next line. Now when you open the credit card account, you're not going to owe any money, so initial amount owed is always set to 0. Okay, you'll owe money when you do shopping. Don't owe any money when you just open it. And I'm going to show you how account number is set automatically. We take our static variable and do pre-increment on it, and that sets the account number. Notice when I create the next account, then it will remember its last value because it's a global variable, and then it will increase by 1 to give the next account number. Okay, so we don't have to ask the user for account number, it will be set automatically. So now I've populated all the fields and I return credit card to the calling block. Okay, you can pause this video and go back to understand more details of this function. If you didn't understand something, go back in the video and see it. That's creating an account. Okay, so next thing I want to show you something very simple. Print account details. So we do the print account function. Okay. That's pretty simple. We could do it without a pointer, by the way, but passing a pointer is more memory efficient, and if you put a const here, that means you cannot change the pointer, so it kind of has one level of protection. Now we're going to jump the definition. Okay, so now since pointer is being passed, we don't have access using ccptr dot. Rather, we have the access using the arrow operator for the member selection. Okay, and I've described arrow operator in previous video. So account number is int type. We print that. ccptr arrow account number gives me access to the account number field, this one here. And then account holder's last name, which is simply, I don't have to actually have a last name field. I can just take the first name, comma, I'm printing the whole name, not the last name, and print. So pointer arrow, first name gives access to the first name field, and pointer arrow, last name gives access to the last name field. Two strings printed, and already I've stripped the end of line characters from both, so we'll get them printed one line, slash n gives us the next line. Now it's interesting how we want to print amount owed, because they may have no balance, they may owe bank the money, or bank might owe them the money. So amount owed is an interesting thing, and we can do a nested if and else to give correct picture. If amount owed, ccptr arrow amount owed will give us access to the amount owed field. If amount owed is greater than 0, then we show them in up to 2 decimal point. You currently owe ccptr amount owed. Okay. Of course, obviously this will be non-zero or positive. It will be positive only after they've done some shopping. But if they paid more than they owe, then bank will owe them the money. In that case, amount owed is negative, and we print your credit balance of Same thing, ccptr arrow amount owed, give access to amount owed field. If it's neither greater than 0 nor less than 0, it's equal to 0, then they owe no money right now. Their balance is 0. Okay? That's the print account operation or function. Okay? Now, when you do shopping, you're going to be charging to the credit card. That's another operation. So let's take a look at that. There you go. We cannot process a credit card charge until we know that what is their available credit. Concept of available credit comes that you cannot exceed the credit limit. You cannot surpass the credit limit. So again, in this case, since we're going to be charging the credit card, we have to pass credit card object pointer and a shopping bill, whatever shopping they did. Let's say they went to Macy's and bought $300 worth of clothes, then their shopping bill will be $300. So first we need to know available credit, and that would be simply credit limit, which in this case has been set 1500 for everyone, and minus the amount owed. And as I said before, pointer to the struct, arrow gives us the member value. So they cannot do, the shopping bill should not exceed available credit. If that's the case, then we tell them you do not have enough available credit to complete the shopping transaction, and you have to decline the transaction. And in that case, amount owed has to remain unchanged because, hey, we declined their shopping. But if this is false, like shopping bill is actually less than or equal to available credit, that means there is enough available credit to do the shopping. So in that case, we're going to approve the transaction. You can do it after that. And add the new shopping bill to the amount owed. Your amount owed is going to increase by the amount of shopping bill. And then we tell them how much they owe now. Okay. Just as a matter of information. Usually when you go to store and do shopping, you don't get that printed out, but we will do that in this case. So this operation does the mutation, and mutation is done to the amount owed that we do here, that we show here. Okay, third operation you may want to do is make a payment to the credit card. Usually that's done at the end of the month, but we're just showing how it's done. So again, when you make a payment, you're going to change the amount owed, and then there is a mutation to the credit card object in that case as well. You need the write access. For write access, we have to pass a pointer to the function pointer, credit card pointer, which can change the pointee. And that is actually one line of code because you're paying to them. So we deduct money paid from the amount owed and store back in the amount owed. And just as a piece of information, if amount owed is less than 0, That means it's negative. We tell them that you have credit balance of that much. Yeah, I mean, this happens all the time, although not too many times, that you owe only 200 and you paid 250, and that's just sitting as a credit for you, and then you can spend $50 more than the credit limit. Okay, so sometimes that happens. But if amount owed is 0, then we'll print that your account is paid in full. If amount owed is greater than 0, that means they owe the money, and then we say now you owe the balance of CCPTR arrow amount owed. So that's the make payment function. We don't have too many more functions to go because we are keeping our software pretty simple. So account holder, especially if she's a woman, may change her name after getting married. So we need to take care of that. Another mutation, and that's done by change last name function. And that's actually very, very simple. Main function will ask for the new last name, and it will pass to the change last name function, and we just do the Struct copy into the last name field. Once again, a pointer has to be passed because we want mutation in the credit card object. Mutation cannot be done by a function unless pointer to the object is passed. Now, when I did fgets in the main function, I may have forgotten to strip the end of line character, but sometime in last name it doesn't matter because you will have end of line character after the last name printing anyhow, but we'll see that when we go to main function. Okay, let's see the main function now. Or actually, better yet, let me just do a simple running of the program first, show you how it works, and then I'm going to show you the main function, which is menu driven. Okay, but you might understand it a little better if I run the program for the time being. Okay. Okay, so we're going to have main menu, which has all these menus. Create a credit card account, print account details, do shopping and charge to credit card, make a payment to credit card, change account holder's last name, inquire available credit, what is my credit limit, exit. Okay. Now, of course, in a good piece of software, other operations should not be allowed until credit card account has been created. We didn't do that yet. That would have increased my lines of code too much. But yeah, that can be done, which will be graying out all the items until this one is used. Okay. Also, in this current piece of software, we'll only be creating one account. If we create a second account, the first one will be deleted. But of course, bank can have many accounts, and that problem will be solved when we create an array of credit card struct. In the next video, we'll do an intro to credit card struct, and possibly we'll do a credit card program with the credit card array where we can store as many credit card accounts as we would like. Okay, so in this case, we'll create the First account 1. Okay, I think I typed 11 rather than 1. So let me type 1 again. Okay, now it's correct. Enter first name Mary, last name Adams. And that's all the information you need first time, because amount owed is set to 0 and account number is created automatically, but you can check that by printing account details. Notice account number 101 has been assigned automatically. Name is Mary Adams, and you owe no money right now. Well, let's do some shopping, which is number 3. And they're going to ask, what is your shopping bill? So let's say Mary shopped at Macy's and spent $200.99. So that went through. It says transaction approved. Now you owe $200.99 on your credit card account. But imagine that next Mary went to Nordstrom and shopping and spent a lot of money. And this time shopping bill was, let's say, $1,400.99. Let's see what happens. It says you do not have enough available credit to complete this shopping transaction. Transaction declined. The reason being, credit limit is $1,500, and she already did $200.99 shopping. If you add that to $1,499, you exceed the credit limit, so transaction is declined. But she can ask her available credit, which is number 6, and it's $1,299. So maybe she can do smaller amount of shopping rather than $1,400. So she does 3 again, and maybe do only $1,000, 0 cent, 1 cent worth of shopping, and that got approved because this is less than credit limit. Okay, imagine that Mary got remarried and she wants to change her last name. So number 5. Okay, I think this may not go through. Sometimes it doesn't work. Yeah, I think I typed 55. So number 5 will work now. So new last name, let's say Johnson. And that's changed successfully, but you can confirm it by printing account details. And it indeed got changed to Mary Johnson from Mary Adams. Let's say she wants to make payment to her credit card, number 4, and she wants to pay maybe $500.30. So that's processed, and her amount owed now reduced. See, earlier it was $1,201. She paid 530 cents, and that got reduced. Okay, so that's pretty much how this piece of software works. I think we have shown all the menu, 6 maybe not, and available credit, 7, what is the credit limit, $1,500. Okay, so last item is exit. We'll exit the software. Now I'm going to show all the details inside the main function, how this menu driven program works. And then I've done more execution of the program, and I can show a few more things in the output that I've done earlier offline. So we use a loop which will be menu driven. You can do that with the do while, but I find flag control loop, while loop equally convenient. And here the blank credit card account that we're gonna use is created outside the loop, because if any mutation is done by any menu item, then that would be reflected in any of the menu item we're going to use later. You cannot declare it inside. Actually, C doesn't allow that anyway. You guys are lucky. And this will be menu choice user is going to make. And I have a couple of other variables: shopping bill, money paid, and when somebody wants to change their last name, the new last name character array, and the length that would be used when I want to strip the end of the line character from the new last name. Okay, you'll see how these are used. So I set a variable called done to 0, which is false, and I do while not done. That means I'm going to enter the loop because I'm not done yet. Negation of 0 will be true, so I'll enter the loop no matter what. So this simulates pretty much like do while loop. And then I have the main menu that you saw earlier here, right here. So each main menu item is a printf statement: create a credit card account, print details, do shopping, make a payment, change account holder last name, and so on. And now here's the beauty of having functions to do each operation. All we have to do is call a relevant function in each menu item. So if they should do this first, if they have choice equal to 1, then this CC is populated by create account function, and we already discussed that. My students will get the copy of this to see it. You can go back to the previous part of the video to see it. And if choice is 2, which is print account details, then we just call the print account function but pass the address, because print account function takes a pointer of credit card type as an argument. If choice 3, do shopping and charge your credit card, then of course we have to ask them what their shopping bill is. Store that into shopping bill variable. Flush, because we could go back and forth in this menu in any order, and we don't want anything in the buffer if we are taking input for a first name or last name. Okay, so each time we do a integer or floating point input, we have to do flush, because somewhere along the line we will be taking input for a string. Okay, so once we get the shopping bill input, we just use the charge to card function, and that also takes a pointer to the credit card, because a mutation has to be done in the credit card object. Anytime mutation has to be done, a pointer must be passed, and we pass the shopping bill. Charge to card looks for the available credit. If this is less than available credit or equal, it will allow shopping, otherwise it will decline the transaction. And choice 4 was make a payment. So we ask user how much money you would like to pay. We store that in money paid variable using scanf. Flush again to delete the leftover character in the stream. And we just call the make payment function. Again, pass the pointer to the credit card because we're making changes, mutation, and pass the money paid. And then make payment function will accordingly reduce the amount owed. Choice 5 was that user wants to change their last name. So we ask them their new last name. F gets it from the keyboard. We delete the end of the line character from the new name, and then change last name function is called. Again, change is being made, so we are passing a pointer to the credit card object, and the new name will be set instead of old last name. Choice 6 was to give them available credit, and that's always credit limit minus the amount owed. If amount owed is actually negative, then it will be higher than the credit limit even. If amount owed is positive, then it will be less than the credit limit. And then choice 7 was print the credit limit. We just print this pound defined value, which was 1500, to 2 decimal points. Choice 8 was exit. If we say done equal to 1, then not 1 will be false and we'll exit the loop. And if they enter anything else other than 1 to 8, well, that's an invalid choice. And we say invalid choice, menu will continue on. Okay, I want to show one more thing, that in this case, if we create another account, then old one will be deleted. But when we use credit card array, which we'll show in the future video, that won't happen. Both will be stored because they'll be stored in different parts of the array. But I just wanted to show that if a new account is created, account number is automatically assigned. A new account number is automatically assigned, which is one more than the previous one. And let's see, I am trying to see where I did that. Yeah. So I did that here. One is missing. There should be one here to create a credit card account. So it asks for the new person's first name and last name. And then if I print the account details using menu option 2, I get a new account number 102, Lisa Jones, new account. But of course, in this case, we are only carrying one credit card object. The old one is deleted. Okay. This problem will be removed once we have array of credit card accounts. Okay, so that's my description of this credit card simulation software. To my students, any portions you didn't understand, you will have access to this listing. In fact, when you watch this video, print this program and have it next to you, you'll understand it a bit easier. Okay, thank you.